Okay, so in the previous video, I introduced the idea of an epidemic modeled on a network using agent-based modeling. And in this video, I'm going to try to describe the code design. Now, one of the tricks to code design is to modularize your code. Break it up into small pieces and then do the pieces one by one. One of the things that is useful in Python is the idea of class. And we'll be using class to modularize the design. Now, class is talked about in the Solo Learn class, and you can always go back and review that. And there's also a great deal of help in Python online about how to use classes. All right, well, in this spreadsheet called Python Model, XLS, I set out different things that are needed in the code. And you can do this in Google Colab or some other platform for Python, however you like. All right, so first of all, we need to initialize some parameters. You need to, if we're talking about epidemic in an area, we need to specify the area. And so I have these parameters xlim and ylim that give the x and y limits geographically, because we have a maybe a rectangular area that we're looking in, and we're looking at people who live in that area. All right, so I took values 0 to 10, 0 to 10 for this, so that's 10 kilometers by 10 kilometers. We can always change that. One of the characteristics of good code is you put all your parameters at the beginning so you can change them at will. Don't ever use a parameter in the body of the program, because then if you want to change the parameter, you have to go hunt through the entire code to find it. So please obey that rule. Do not put any parameters at all in the body of your code. Put your parameters at the beginning of the code. Okay, so here we have xlim and ylim. We also have to decide the number of homes. We can start with 50. And the maximum number of agents. Now, agents are the people who populate the region, so we'll put 300. All right, so this is probably a small number, but we can start with this. It's good to start small and make sure that your code is working. All right, so I mentioned that the key to this code is classes. So we're going to define three types of classes: institutions, homes, and agents. All right, the institutions are places that people visit. And these include, in this case, I'm going to include 4 institutions. Sorry, this is a mistake here. This should be high school, elementary school, high school, supermarket, and workplace. So these are the 4 types of institutions we'll be looking at. And we're going to define a class for each of these, but all of these belong to the institutions class. All right, or institution class. All right, so we're going to actually create 4 instances of this class. Each one of these instances will be an object of class institution. Now, if you remember from the Solo Learn tutorial, classes have attributes. And these are the attributes that you need to assign to this institution. And remember, when you define the class, you have to define the attributes. And here they are: the name. It'll be the name of the type of institution, which will be one of these: elementary school, high school, supermarket, and workplace. Okay, so for instance, you will define a class, instance of institution with name elementary school, and we'll use the name as one of the attributes in that class. All right. Each class should also have nvis, which is probability distribution of the number of institutions visited. So I'll explain that down here. I gave an example of how to initialize that. Okay. Distance exponent, and I'll explain that later. The point is that each institution, there has to be a probability of the agent visiting that institution, and that's going to depend on the distance between the institution and the agent's home. So we'll use that later. That will be a little bit involved. We have XY location, which are the X and Y locations of institutions of this type. Now, in the elementary school instance of institution, we will have a list of all of the X and Y locations of all elementary schools. And that will be in this elementary school class. That will be an attribute of this elementary school class. So in other words, the elementary school instance is going to describe everything we need to know about all the elementary schools in the model. All right, PViz is the probability of visits. And this is going to depend on the type of agent. I'll explain this more below, where I talk about how to initialize this. We have pint, which is the probability of an infectious encounter with each other agent. All right. So the agents who visit or are at this institution at any particular day have some probability of infecting any other individual who's at that institution that day. And that's where this comes in. And so here we have ID AG, which are the IDs of people, of the agents who visit institutions of this type. Instead of people there, I'm going to say agents, all right? Because I'm using agent as a word for people in this case. Sometimes agents are more than one person, but I'm trying to be generic. So I'm going to use agents instead of people. So these are the IDs of agents who visit, and this is the probability of visiting for agents who visit, all right? These two will be specified later, but these others are initialized when you define the class. So you'll create four institutions of institution, create four instances of institution with the following names: elementary school, high school, supermarket, and workplace. And like I said, for instance, the supermarket instance will contain all the information about supermarkets in the model. And there will be more than one supermarket, all right? So these are the attributes for elementary school. The name, we'll just call it this. Okay? It's going to be the same name as the name of the instance. All right? But this is an attribute of that instance. Now, NViz, as I said, it's going to be a dictionary. Now, you also had dictionary in the SoloLearn tutorial. I can refer you back to dictionaries here, right? If you look at how dictionaries are defined, dictionaries have keys, and to define the dictionary, you use these curly brackets. You put the key in quotes, colon, and then you put the initial value that's associated with that key. And then to invoke those values, we take ages, square brackets, and use the key. All right, so that's dictionaries. Just to go back and so you can see, there's also the one on classes here. Where is it? Somewhere here. Let's see, where's the one on classes? Oh, here we go. All right, they talk about classes here. Right, here's the class, and here you define it, and these are the attributes, right? So these are the attributes that I'm talking about here. Each one of these attributes here, for instance, name, NViz, dist, xyloc, those will all be attributes that you put in this list. And then you will do this kind of thing to initialize. All right. So I'm telling you how to initialize here. So, like I said, NViz is the number of visits. So here are the list values. So the list for adult is going to have the single value 1. The list for teen is going to have the single value 1. The list for pry is going to have two values, 0 and 1. Now, what does this mean? This means that the adult does not visit any elementary school. A teen does not visit any elementary school. The primary visits one elementary school. All right, so that's what we're doing. Now, it's quite possible that the adult might visit the elementary school sometimes, but rarely. All right, when we're doing a initial model, we want to model the basic behavior and not model the things that happen rarely. Now, we can always change this later if we need to. But these list values indicate that the adult never, so this here it says, this means that the adult visits 0 institutions with probably 1. The teen visits 0 institutions with probably 1. The primary visits 0 primary schools with probability 0 and 1 primary school with probability 1. So we're assuming that every primary student goes to primary school. Of course, I'm not including homeschooling. That's something that we could we could include later. All right. Here's the distance exponent. That's going to be minus 10. So that's an attribute that you can initialize like this. These are the XY locations of the elementary schools. And this is in a 10 by 10 radius. So you can see these are all between 0 and 10. All right. So this is going to be, as it says up here, you're going to enter this as a 2 by n NumPy array. Actually, it says here, I'm going to change that. That's not a list of pairs. That's going to be a 2 by n NumPy array. It's better to use arrays. All right. So that's how we're going to define this. Now, why do we have 2? Because we have x coordinate and y coordinate. And then we have n, which n is going to be the number of institutions. All right. Then pviz is also a dictionary key. Now notice that these have the same shape as these up here. I want to know for these institutions that they visit, how often do they visit this institution? Right. So here, because here the adult and the teen never visit the institution, I can just put 0 here. The primary student will visit his assigned primary school 95% of the days. Now notice that in practice, you'd have weekdays and weekends. I'm just going to model weekdays. In a more sophisticated model, we could easily model weekdays and weekends. That's not a problem. But let's start with a let's not put too much complication in the model. All right. All right. Now here we have pinf, which is 2.1. Now actually I'm going to change this. I'm going to call this ninf instead of pinf. And I'm going to change the meaning here because this is what I actually mean. This is going to be what this is going to be is the average number of people infected. It's going to be the average number of people infected, of agents infected by an infectious agent per day. Okay. All right, that's actually quite high. I may want to change that and make it lower. That's really quite high. Why don't we make it a little bit lower? We can make it let's make it 0.5, something like that. All right. So what that means is that every visit of an infectious person, on average, that infectious person will infect 1/2 of a person per day, or one person every 2 days. This IAGT and PAGT, we'll talk about that later. All right. So these are the attributes for elementary school. I have a similar list for high school. For high school, this list is very similar. I'm going to skip that. Let me explain how it's a little bit different so this should be ninf, and I think I'm going to change that to 0.5 again. Because okay, that's a little bit high. Okay. All right. Now for a supermarket, let's see how this is a little bit different. All right. What this is saying is that an adult visits 0 supermarkets. Any particular adult agent visits 0 supermarkets with probability 0.2, visits 1 supermarket with probability 0.4, 2 supermarkets with probability 0.3, and 3 supermarkets with 0.1. Okay, so this is talking about the supermarkets that the adult often visits. Adult in this class would be one who always shops in the same place. An adult with this class would be one who shops in 2 different places. This one shops regularly in 3 different places. Now again, we're not talking about exceptional cases. We're talking about what they do regularly on a daily basis. All right. Here for teen, I put 0.8 and 0.2 because you might have teens who have jobs at a market. Okay, so say 20% of teens have jobs in the market. Okay, and primary, I don't need a 0 here. It's just say primary never goes to a supermarket. All right, now primary might go to a supermarket with an adult, but you think that the primary is probably in the shopping cart and won't have much contact with people. So the primary is probably not going to contact. Again, they're simplifying approximations here. We can't do a perfect model, but at least we want to capture some of the behavior. Distance exponent, I'm going to leave that. Xlock, again, this is a 2 by n array. There are 5 supermarkets in this model, and these are the x and y coordinates, and that's going to be a 2 by n numpy array. Here I have pvisit. You can see that this has the same shape as here. This, for instance, these here. Now I see now I'm going to have to revise these values, because if the adult visits 0 stores, then there's probability 0 that they're going to visit. And then now these don't add up to 1. This is going to be 1. And this, let's see, let's put, if we put this in the ratio 3, 2, 1, then this would be 0.5. And then this would be 0.33. And then this would be 0.17. And what that means is that if, for instance, if the adult does have 3 stores, it visits them in this ratio of frequencies. Right. We'll talk more about that later, but you can just key that in for now. But again, these are the dictionary keys, and these are the list values. All right, P infection, again, I think this is a little bit high. Let's make this 0.3, and then these are to be specified. Okay. Now, supermarket is, let's see, supermarket here. All right, so I'll have to fix this. We're going to make this one workplace. I'll fix that. I'll fix that offline. In the document that you get, I will change this to workplace. All right. So those are the institution classes. Homes class, we're just going to define one instance of homes class. And the homes class, the attributes are the residents of each type, which will be, there will be some adults, some teens, and some primary in every home. The infectivity at home, for instance, what's the probability that someone who goes home will infect someone else at home on any given day? The XY locations of all homes, and the IDs of agents in all homes. So this is, in fact, going to be a list. It's going to be a list of arrays. Because each home is going to have a different list of residents. So I can call these resident agent IDs. Okay, all right. So here's my attribute values. The distribution of residents of each type. What this means there's probability 0 that there are no adults, probably 0.3 that there's 1 adult, probably 0.62 adults, probably 0.1 of 3 adults. Okay, for teen, probably 0.3 no teens, etc. Primary, probably 0.3 no primary, etc. All right. Now, P-inf is the probability that any person at home will infect another person at home during one given day. The XY locations will do this, will initialize this later, and the IDs will initialize that later also. Okay, and these attributes correspond to these here. All right. All right. Now we have one more class, which is the agent class, and that's here. That's going to describe all the agents in the simulation. And when you define this class, you'll have three attributes: type, and this is going to be a list of agent types. And the different types are pri, teen, and adult. Of course, when you do these, you'll have to have quotation marks around it. Pri, teen, and adult. Okay. All right. All right. Now, we'll also have status, and this is where the disease status of each agent will come in. So we'll have a number that indicates the status of each agent. And I'll tell you how to do that. We're going to do it a little bit better than the way it's done in the SIR model. I'll have a more realistic way. The way the SIR model works is that the durations are duration of infection is very random, and it's not really so realistic. We can give a much more realistic model of the duration of infection. And then home, here we give the index of the home, because we also want to key the agent to which home they're in. So notice that we have the index of the agent in the home class, and we have the index of the home in the agent class. So we can go back and forth between the two. All right, so those are our classes. So your first task will be to initialize these parameters, which will basically be 4 statements. And then you'll also initialize these classes. You'll define these classes, and you'll define instances of these classes. All right. As I said, you'll define 4 instances of the institutions class. You'll define 1 instance of the homes class, and you'll define 1 instance of the agent class. Right? Okay. And I should probably call this agents instead of agent, because it is agents. It's not just a single agent. So let me change that to agents. That's a more accurate name. Okay. Now this last tab here, I give the pseudocode. So you can start off like this. So you'll have to define the classes. Actually, I should leave something here. I should put here, first you want to initialize parameters. Okay. And then here you want to create the classes. As I said, you're going to create these 4 instances of institutions, 1 instance of homes class, 1 instance of agents class. Okay. And we're also going to create a list of institutions, which will simply be a list consisting of these 4 classes. Okay. So if you can get this far at the beginning, that will be good. Once we get there, then we can go on to the next step.